Hello. In this video, I'm going to solve through an example problem analyzing stress at a point with stress transformation. Okay, so here we have the plane stress set up. Sigma x, 20 megapascals. Sigma y, 120 megapascals. Both of those are tension, so positive. Shear stress, tau xy, negative 80 megapascals. You can see it's negative on the right side. It's going clockwise direction, negative. And we're going to be looking at the stress on this inclined plane that makes a 56-degree angle from the vertical. Okay, so you can see here I have a theta of 124 degrees. What I did was I put x1 and y1, or n and t, where n/x1 is normal to the inclined surface, and y1 as it has to be counterclockwise 90 degrees from that. And if you do a little bit of math for the angle, you'll find that this makes 124 degrees from the horizontal, from x1, or from the x-axis. Just like before, we can look at our stress transformation equations, and here we have x to x1, that's theta. This time it's 124 degrees. So we can put this into our equations. We get normal stress sigma x1 x1 162.91 megapascals, sigma y1 y1 negative 22.91 megapascals, and the shear stress to be negative 16.39 megapascals. And we can do our check. You sum up original normal stress for x and y, then you sum up the new ones. They both come out to 140 degrees, so that we know that we're on the right track here. However, this 124 degrees, it's more than 90 degrees, so you can't just solve it like this with our MechMat software. So here, I have put in the information. We got 20, 120, negative 80. And here's our original plane stress. And we have to get it so that theta is less than or equal to 90 degrees. As you can see, I have it set to theta being 34 degrees. And the way I did that is, instead of setting x1 to be normal to the inclined surface, I set x1 to be tangent to the inclined surface, so that from x to x1, that makes an angle of 34 degrees. And now y1 is the normal to the inclined surface. So you can put this in there. It's the same number as before, just change the angle. We can put it in here, 34. We have negative 22.91, 162.91, and 16.39. These still add up to 140. As you can see, compared to the first one, x and y are swapped, and there's a sign change on the shear stress. Why is that? Well, for the original problem, you can see that the positive for the axis that is tangent to the inclined plane, for this one it's y1, and its positive is pointing downward. However, when you look at the other setup, the tangent axis has the positive direction of going upward along the inclined plane. You can see that itself is a sign change. So for this first one, the shear is coming out to negative, so that means it's actually going to be going into the negative y1, which would be upward along the inclined plane. And here in this one, the positive already is upward along the inclined plane, and the answer comes out as positive. So that's pretty much it, just very similar to the first example problem, just working with changing the way your axes are set up. And the thing to remember is that you can set it up the way, however way you want it, but x1 to y1 always has to be counterclockwise from each other, 90 degrees. And we purposely set x1 to be as close to x as possible to try and get that below 90 degrees angle. So that's pretty much it. In the following example problems, I'm going to be working with some more advanced problems.